Hey guys, and welcome to the next video in the series of sketching parabolas. Today we are going to be continuing on where we left off and showing you exactly how to do quick sketches based on the equations that you're given. Now in the last video I explained that it's very important that you revise and start to memorize each of the equations that we learnt and having a look at how adding numbers, subtracting numbers, putting them in brackets, putting it before the x squared term, changes the look of a parabola. Now the reason why is because we're going to use that information to help us solve a few of these questions. Now for this example, for the volume of questions that you guys will be doing in this exercise, we have allowed you to simply sketch the parabolas in your book. This means that it is okay to freehand your axes and to freehand your parabola, and it will generally look messy in your book. However, this is not going to be allowed for the test, and it is definitely not going to be allowed for the exam. This is simply because there are a lot of questions to do, and we don't want you spending time, hours and hours at night, drawing up axes for your parabolas. However, you will need to make sure that they are clearly labelled, and for the exam you will be required to have a ruler because there won't be such a large number of questions. Okay, so looking at our first example, x squared plus 4. Now hopefully you've learnt and memorized each of your different equations from exercise 6a, and you'll know that when we add numbers to the end of the x squared, it moves it up and down the y-axis. Now in this case, it is going to be moving it up the y-axis 4 units. Now in the previous slide I showed you that you can do a quick messy graph as long as you put and label the most important information. But remember, this is not going to be acceptable for the test. So here's all you need to do. You quickly draw up a quick axis in your book, you draw a quick parabola, and you label in the fact that it turns at the number 4 on which axis? The y-axis, and this one here is your x-axis. So I've labeled my two axes, I've labeled where it's turning around. Now I just need to make a couple more statements before I finish this question. First of all, the turning point is at the coordinate 0, 4, and I need to make the statement showing exactly what it's changed, and it has moved 4 units up. So for this example, all I've done is a quick sketch to illustrate visually how this graph has changed, and then I've written the most important information down. The new turning point is at 0, 4, and the parabola has just moved 4 units up from its original position. So because of the volume of questions that you're doing, you can just do this as your answer, but for a exam or test question, you'll need to do this more neatly with your axes neatly ruled, and the parabola is done pretty much the same. Okay, let's have a look at the next one. What is going to change with x squared minus 3? Well, hopefully you remember that this is going to be similar to the previous one in that because it is subtracting 3, now it's going to be moving down the y-axis. So here are our two axes again. Here's my y, here is my x, and the parabola is going to be coming all the way down here, and I'll label exactly where it's going down to. It's minus 3, and again put my two pieces of information. The turning point is at 0 and minus 3. And what's happened? Well, it's moved 3 units down. And that's all we need to do. Okay, next example. X squared plus 10. Well, same thing. Quickly draw up our axes. Draw in our parabola. This time, it's moved up 10 units. So two pieces of information once I've put in my axes, labelled them properly, otherwise I'll lose myself some marks. The turning point is at 0, 10. And what's happened? Well, it's moved up 10 units. And that's it. Okay, what about this one? Quickly draw up my axes. Label them Y and X. Draw my parabola in. And what's happened? It's moved down 4.5, so I'll put in a point here, minus 4.5. And my two pieces of information, the turning point is at 0 and minus 4.5. And what's happened? Well, it's moved down 4.5 units. So again, exercise 6b is simply just providing another chance for you guys to practice these graphs and trying to memorize exactly what happens when you add, subtract, or even multiply different numbers into your equation. Alright, example number 2. Let's do some practice with the numbers inside the brackets. So again, first things first, we'll quickly sketch up our axes and label them Y and X. Now think back to exercise 6a. What happened when we put our numbers inside the brackets and squared them? How did that translate the basic x squared graph? Well, hopefully you remember that either adding or subtracting numbers moves the graph to the left or to the right. In this case, because we're adding, it's going to move it to the left. So here's our graph. It's not supposed to go underneath. Here it is. It's moved across to -1. And again, my two pieces of information. The turning point, because it's moved to the left, is 0. And, oh, we got this around the wrong way. We've moved it across the x-axis this time, not the y-axis. So it's moved it across to -1, 0. And I'll tell the reader that it's moved left 1 unit. And the purpose of this statement is simply just to help the fact that I've drawn a pretty terrible graph, and they can see, oh well, I know it's not supposed to look exactly like that, but he's told me that it's just move left 1 unit. Okay, let's have a look at the next one. Alright, it's got a minus sign, so we're moving in the opposite direction. We're moving to the right this time. Okay, so putting in our axes, here's our Y and our X. Drawing our parabola, let's move to the right this time. Make sure it just touches the x-axis. Put in our turning point. Where is it going to be? Yes, at the number 6. And our two pieces of information. The turning point is at 6, 0. It's moved across 6 units. So I'll say it's moved right by 6 units. And that's it. Okay, let's do the next one. Right, x plus 25. So first thing we need to do is draw in our units. So you notice how each of these examples has been split into each of the different types of translating. You've got up and down. Now example 2 is left and right. So let's do this one now. We've got y, x, but the test won't necessarily be that easy. So we'll put in our parabola now, make sure it just touches and then goes back up again. And where does it touch? Looking at our formula, 25. Okay, now putting in our pieces of information, the turning point is now at 25 and 0. And what's happened? Well, it's moved right 25 units. Okay, let's look at this question. X plus 25 squared. And the question I want to ask you is, have I done this graph right? What do you reckon? Have I done it right? Have I done it wrong? Okay. What I have illustrated is a common mistake that some people make with this particular type of graph. And what I've illustrated is simply because it's got a plus 25 doesn't mean you always go to the positive number on the x and y axis. In example 1, we were lucky because the plus numbers meant it went up. but the negative numbers meant to when to go down. But with example 2, it's a little bit different. Let's look at the previous page and notice what I did. What happened when I did the plus numbers on this side? It moved to the left. And when I did the minus numbers, it moved to the right. It's very important that you make the distinction early and don't get into a bad habit of always following the numbers that are listed in the equation. Just because they're positive here doesn't mean they're going to be positive on your graph. So getting back to this one, this graph is actually wrong. Let's do it again correctly. Okay, so our equation is x plus 25. That means we need to be going to the left, not to the right. So here's our y and our x axis. So it's over this side. Just touches and goes back up again. So the number is minus 25. So our turning point is actually 0. Oh, it's not. I got confused again. It's not on the y-axis. It's minus 25 on the x-axis and 0 on the y-axis. It's very easy to get these around the wrong way if you're not paying attention. Okay, so our turning point is minus 25 and 0, and I need to say that it is moved left by 25 units. And that's all I have to do. Remember, when we add, it goes to the left, and when we subtract, it goes to the right. Okay, so looking at this one, we're subtracting by 2.25. So put in our axes again. Which way are we going to go? Left or right? Yes, we go to the right. There it is, just touch the axis at 2.25. Our turning point is 2.25 and 0. We can say that it is moved 2.25 units right. Awesome. Okay, example number 3. Alright, so this time we're changing the number in front of the x squared. What's going to happen here? We should remember that from our previous exercise that when we increase the number in front of the x squared, it thins the graph. It makes it thinner. So here is our axes. Got our x and our y. Let's draw a nice thin graph. Okay, the turning point hasn't changed. It's still the original 0, 0. But what's happened? The graph is thinner. And you could say by a factor of 3 if you would like. Okay, next one. This is a fraction. It's less than 1. And what happened to graphs that were less than 1 but greater than 0? Well, they became wider. So 2 over 5, let's draw a wide graph. There we go. Okay, the turning point hasn't changed. It hasn't moved at all. It's just 0, 0. But the graph is wider. Nice, easy one. Alright, there's a couple more in example 3, but let's move on to example number 4. Alright, we had this one in example, what was it? Example number 4, was it? In exercise 6a? Y equals minus x squared. What happens when we put a minus sign in front of the x squared? Well, hopefully you remember this one too. Let's draw up our axes. It flips it upside down. So here's our graph. Comes up, touches, and goes back down again. Again, this one still hasn't changed. The turning point is still 0, 0. Hasn't changed from the x squared. But what has happened? It is, you could say it in a few ways. It's the mirror image, or you can say it's been flipped over the y-axis. Flipper. No, flipped. Okay, last one. y equals minus x squared plus 3. Ooh, this is a hard one because we've got a combination. We've got a minus and we've got plus 3. Let's see what that does. Well, first of all, we know from the previous one that we just did that when we put a minus, it's going to flip it over. Okay, so putting our axes y and x. Now, can you remember what happens? This is example number 1. What happens when we plus 3 to it? That's right, it moves it up the y-axis. So it's going to come up here, it's going to go over, and then it's going to come back down again. And where? This is at the number 3. So the turning point is different from the previous one. It's 0, 3, but what's happened? Well, it's moved up 3 units, but also, and it's flipped, not flipper, flipped over the, oh, not the y-axis, the x-axis, sorry. I've changed that in the other one as well. Goodness me, I'm having a shocker of a day. X-axis. Alright, so this is what we're doing in exercise 6b. We're expanding and memorizing and revising all of those lovely rules that we looked at in exercise 6a. And hopefully once you've done a bit of practice in this, you're going to start get the hang of looking at an equation going, ah, I know exactly what's going on here. It's moving to the left, or it's moving up, or it's flipping, or rotating, or whatever crazy thing we're going to do to it. You need to start learning and memorizing those, and hopefully by the time you get to class tomorrow, you'll have it all down pat. I've been Mr. Rappell. I'll see you guys in class tomorrow. Fun!